Liftoff. Set for 5, aim high. Take off and go Dragon.
And we are down.
Good afternoon. My name is Bettina Klein. I'm with NASA Communications, and welcome to this post-launch press conference talking about the in-flight abort of SpaceX's Crew Dragon, an important part of NASA's Commercial Crew Program. Today with us, we have some great guests who will provide some remarks. First will be Jim Bridenstine, NASA Administrator, Elon Musk, Chief Engineer at SpaceX, Kathy Leaders, the Program Manager for Commercial Crew Program at NASA, and astronauts Mike Hopkins and Victor Glover. They'll begin with, as I mentioned, opening remarks, and then we'll open it to questions from both the members, the media in the audience, and those who have called via the phone, and also social media. You can ask your questions on social media by using the hashtag AskNASA. With that, let's kick it off with Administrator Jim Bridenstine.
Well, thank you, Bettina. Another amazing milestone is complete for our very soon-to-be project, which is launching American astronauts on American rockets from American soil for the first time since the retirement of the space shuttles. We're very grateful. Congratulations to SpaceX and the entire NASA team on this final major flight milestone that we needed to accomplish. Make no mistake, there's a lot left to do. We have a number of parachute tests upcoming, and of course we're going to get a lot of data from this particular test, and so we're not quite there yet, but by all accounts this was a very successful test. And when we think about what we have done so far with the Crew Dragon, we've had a pad abort test that was successful. We've had now a high altitude abort test that has been successful. On Demo 1, we launched, we controlled the spacecraft, we docked to the International Space Station, we undocked, and then we had entry, descent, and landing. So this is a program that is moving forward very fast, and I personally want to give my strongest congratulations to the NASA team, which has been amazing, and of course the SpaceX team, which has also been amazing. So congratulations to everybody involved, and I'll turn it over to Elon.
All right. Well, let's see. I'd like to, likewise, just express great appreciation and admiration for the SpaceX and NASA teams that made this happen. Without a lot of dedicated people at SpaceX and NASA, this would not have happened. So it's just thank you for your hard work and dedication to achieving this the success of this mission. There's I think a few points that are kind of exciting to note. That the peak velocity of Dragon during abort was more than double the speed of sound. It went to Mach 2.2 and achieved an altitude of 40 kilometers or 131,000 feet. So I think these are pretty exciting specs, to be for the sport to have gone more than 3 times the altitude of a typical airliner, and to accelerate that rapidly away from a booster. And I think if you saw in the video that the booster actually exploded as expected. So that was very exciting, and it landed in relatively high winds at the ocean level, which I think helps us envelope the mission for when it is crewed, since we expect this to be sort of an enveloping condition for the winds at sea level at the recovery site for when crews are launched. So overall, as far as we can tell thus far, it is a picture-perfect mission. It went as well as one could possibly expect. And again, dedication. This is a reflection of the dedication of the hard work of the SpaceX and NASA teams to achieve this goal. Obviously, I'm super fired up. This is great. It's really great. And we're looking forward to the next step. And I think we'll talk more about next steps as we get further into comments.
And I'm super fired up too. This is really exciting. As we talked about when we all got together, gosh, was it a couple of days ago? We said this was going to be an exciting test. My boss told me, hey, don't talk about launch vehicle launches and exciting at the same time. But I think you guys saw today that it was a very exciting test. I'm also super proud of the team. I really appreciate the comments from Jim and Elon. Not only was it a NASA SpaceX team, it was a multi-agency, the FAA, the Air Force, the DET, everybody's out there, made sure that we had imagery assets and the ability to be able to accomplish this mission. And honestly, folks are out there right now recovering the spacecraft, which is going to be very, very critical for us. We're super excited that it all went well. You know, we talked about needing to thread the needle with all the weather, and we did. We did have to thread the needle. In fact, the needle was getting, the head, the eye was getting smaller and smaller and smaller, and all this will be good data for us and for our crews that will be flying soon. So thank you, Elon, to your team. Fabulous job. Thank you to the NASA team. Fabulous job, and looking forward to the next steps.
Okay, I guess it's my turn. Wow, what a day. Yeah, I also want to say it's very exciting to see this. And it's great to get to this major test milestone. We appreciate certainly all of the hard work that the NASA and the SpaceX teams and everybody else that made this event happen. As crew members, our families, you can imagine, we're very interested in these escape systems and how well they work. And so we're going to be following very closely as the data comes in and we continue to analyze it and see what that means. And in fact, the work is ongoing, as was mentioned. The recovery operations, Bob and Doug, the DM2 crew, are actually taking this opportunity to follow those operations and see what they can learn from that. Because this is one of the first time, or one of the only times they'll have an opportunity to see those operations when it's not them. So again, congratulations, and we look forward to the next steps as well.
And since my comments are the only thing between us and your questions, I'll keep it brief. First, to our families that are out there watching, a lot of them were very interested in this test for obvious reasons, and so far what we've seen is what we expected. So that's the first one. And then to you all, the team that has helped make this happen, SpaceX, NASA, the Air Force, and all of the folks who worked so hard to get us to this point, from the crew, but also from our families, we want to say thank you.
Well, thank you, everyone. We're going to now take questions from the media. We'll take a few questions here, and then we'll go to those that have called in social media. With that, we'll first start with Marcia.
Marcia Dunn, Associated Press. Elon, Kathy told us the other day that you could carry crew as soon as March. Is that feasible, and when do you think the crew launch might be?
Well, we were just talking about this in the green room, and my guess is the first question that will be asked is. So we agreed on a response. So it's collectively. This is not. So the hardware necessary for the first crewed launch, we believe, will be ready by the end of February. However, there's still a lot of work once the hardware is ready to just cross-check everything, triple-check, quadruple-check, go over everything again until every stone has been turned over 3 or 4 times. And then there's also the schedule for getting to space station. So because space station has a lot of things going to it. So what's the right timing for this? And the sort of collective wisdom at this point is that we think we're highly confident the hardware will be ready in Q1, most likely end of February, but no later than March, and that we think it appears probable that the first crewed launch would occur in the second quarter.
Oh, I think that's a very fair assessment. I would also say we have to make some decisions on our end from a NASA perspective Do we want that first crew to be a short duration, or do we want it to be a longer duration? If it's going to be a longer duration, then we have to have some additional training for our astronauts to actually be prepared to do things on the International Space Station that we weren't planning to have that initial test crew necessarily do. So we've got to look at that and make a determination. Do we want that first crew to be longer duration, or do we want them to be a quick turnaround? And those are decisions that we're going to be making in the coming weeks. But as Elon said, there's a lot of we have to understand all of the data. This was a test. It looked beautiful. We all loved watching it. But now the work begins for evaluating everything that we're going to learn on this test.
Yeah. To be clear, the data or telemetry all looks picture perfect, at least as far as we've seen thus far. But we need to physically recover the spacecraft and confirm that there's not something that not an issue that perhaps didn't show up on telemetry. Yeah.
Next question. Chris Davenport.
Hi, Chris Davenport from the Washington Post. I guess for Elon and Jim, and I wonder if you chose this as the second question in your betting pool, if you could talk about how profound it would be and what it would mean to restore human spaceflight from U.S. soil. It seems like we're at a real turning point, and it's just that closer, what that would mean from both SpaceX perspective and from NASA's. Thank you.
I'll let you go, Elon.
Oh, okay. I was going to let you. Well, I think it's really quite profound. I think the United States is very much a nation of explorers, a distillation of the human spirit of exploration, and it's obviously something that appeals to people with who have an adventurous. Anyone who has an adventurous bone in their body is going to be very excited about this, and I think it will help reinvigorate interest in space. It's remarkable to think that the last time that a crewed launch vehicle departed from the United States was, I believe, 2011 or thereabouts. So it's been almost a decade, which is remarkable. And so I think it would be really profound to have that. It's kind of to be back in the saddle again and to be launching frequently with an astronaut crew. I think it's something that matters to all Americans and to people worldwide.
And I would say certainly we are 100%. We are a nation of explorers. We're also a nation that leads, and this, of course, represents us returning American astronauts to space on American rockets from American soil. So this is a great opportunity for us to once again lead. And this time when we lead, we're doing it differently than we've ever done it before. NASA is going to be a customer. We're going to be one customer of many customers, and we want Elon to have lots of customers. But we also want to have numerous providers. We need dissimilar redundancy. You guys have heard me say this. I'm going to keep saying it. We've had days in this country where we lost a space shuttle and our space program was down for a period of years at a time. We need to make sure that we have redundancy in a way that doesn't happen again. And of course, if we look at what we've done with commercial resupply to the International Space Station, there's a perfect example of how sometimes when there is a setback, we can continue to move forward because we have other solution sets to accomplish the objectives. So all of this is important for a very specific reason. We're on the cusp of commercializing low Earth orbit. I want to see large amounts of capital flowing into activities that include humans in space. And those activities could be industrialized biomedicine, it could be advanced materials, and it could be people that want to go to space for tourism purposes. But I will tell you this, there is a future where space is commercialized. And I also want to be clear that NASA will always have a presence in low Earth orbit. We are not, there's a lot left to learn. We are only on the beginning of what we're going to learn. So what does that mean? That means NASA is going to be a customer. We just want to make sure there are customers that are not just NASA. That drives down our costs, it increases our access, and it's not just for us, but for the entire world and for the private sector as well.
Next question. Lauren, second row.
Hi, Lauren Gresh with The Verge. The explosion that happened today with the Falcon 9 looked really cool, but I'm curious to know what would happen if an explosion like that occurred while the Crew Dragon was still attached. The Crew Dragon was quite a bit away when it occurred, but is there any concern about that happening for the crew's safety, and how quickly does that capsule move away in those first couple of seconds?
Sure. In principle, the system is designed to withstand a sort of a first stage booster explosion that is, or upstage explosion that is there. That happens when basically even before the escape event. So it's intended to be very robust in principle. And the way to think of the rocket booster is it's less of an explosion than it is a fire. So it's a fireball, but it's much more a fireball than it is an overpressure event like an explosion. Since the spacecraft has a very powerful base heat shield and even leeward side heat shield, it should be really not significantly affected by a fireball. So it could quite literally, like something out of Star Wars, fly right out of the fireball. So that's obviously we want to avoid doing that, but but it is really meant to be something that can fly out of the fireball. There may be a few points that are worth mentioning. That in how is Dragon better than some what was done, say, during the Apollo era. The fact that the launch abort system is integrated with the spacecraft, with the Super Draco thrusters in the sidewall, means that you have launch abort capability all the way to orbit. And whereas previously with the launch escape tower, that because it's so heavy, that is discarded often just 20 or 30% of the time into flight. So shortly, not long after liftoff, the typically launch escape tower, which is a sort of the historical architecture, would be discarded. So you would lose the ability to abort after that point. Whereas Dragon has abort capability all the way to orbit. And then if you have a state change, anything that's a significant state change post liftoff is something to be concerned about. And not having to eject the launch escape tower, I think, is also an improvement in safety. So I think those two are significant steps in the right direction. There's also an improved ability for reusability. Since you're not throwing away the launch escape tower, you retain the Super Draco thrusters. That you can now reuse the launch escape system with every flight, because it should hopefully be very rare that the escape thrusters are used. So that I think those three points are a meaningful improvement over designs in the past. And then one of the things we obviously this requires ongoing discussions with NASA, but I think it would be quite cool to use the boats that we are using to catch the fairing, once that is really well established, to catch Dragon as it's coming in from orbit, and then that would alleviate some of the constraints around a water landing. But that's obviously there's some time before making that happen, and we obviously need to recover fairings reliably before we would consider trying to catch the Dragon. But I think that would be also an improvement as opposed to landing in the water.
And if I can just add one thing to what Elon's saying, one of the most important things is that we're monitoring the vehicle, the launch vehicle, to make sure that you're recognizing when the launch vehicle is having a problem so that the abort system's working, right? So we've spent a lot of time together talking about, how does the spacecraft monitor the launch vehicle and then make sure that it's going to abort before it starts getting into those situations too, right? So all the things Elon's kind of like icing on the cake and additional. The spacecraft's robust. It can handle, these kinds of situations, but more importantly, we're getting the crew away before you're before the launch vehicle is in a position where you're having to expose the crew to the fireball, right?
So and everything he said is absolutely accurate. There are huge advantages to integrating the launch abort system into the spacecraft itself, and those advantages are we can abort all the way out to almost space. The downside is it's engineeringly it's a very difficult thing to achieve, and of course we learned that back in April when we had some oxidizer go into the pressurant system and resulted in a catastrophic loss. But that's why we do these things. That's why we test. And because of the way we're acquiring this, we have very innovative partners that are doing things that have never been done before with a purpose. The purpose is to ultimately save lives, drive down costs, and increase access to space. So all of these things are working. It is absolutely true that we will have setbacks as we learn these things, but it is also true that we are going to be better off for it. And of course, what Kathy said is absolutely true as well. This spacecraft knows precisely where it is in space. Latitude, when I say space, I don't mean outer space, I just mean in space in general. Latitude, longitude, altitude, yaw, pitch, roll, trajectory, velocity. It constantly knows where it's supposed to be, and it knows what's happening to it. And so it can make a determination early, before the explosion were to happen, to execute the launch abort capability. So I think we're where we need to be. But it hasn't been without pain, and going forward, we're going to be better for it.
Great. Joey, second row. Yeah.
Question for Jim and Elon. First, Elon, will you be able to recover any of the Falcon 9 or its second stage? How badly damaged was it when it hit the ocean? And have you? There was a pretty tall plume of smoke, so I don't know. And for future Crew Dragon missions, have you signed up any private astronaut missions yet? Does this test kind of push forward any agreements with that? And for Bridenstine, similarly, have you signed up any international partners? And what does this mission mean for that? Thanks.
Well, there's definitely not any big pieces of the rocket left. If you saw something, there was a sort of object that was sort of falling. We think that's most likely the thrust structure of the first stage propulsion section, which is extra robust and has the engines in it. But that is going to hit the water hard and then be somewhere down at the bottom of the ocean. So we're not expecting to recover anything. In general, we would not expect to recover anything in a launch abort scenario. So that it seems quite unlikely. Yeah. I think we don't have any anything to announce in that regard at this time.
I think we need more customers, is what I think.
Yeah.
But on the international front, you should know this. We have no shortage of partners that are wanting to have access to space, and this is going to give not just us, but them additional access to space. We don't have any agreements at this point to ride on these vehicles, although we're going to have, the International Space Station, we've got 15 nations that operate it. We've had astronauts from 19 different nations, and we anticipate those partnerships all to go forward. And of course, they're going to be very excited about riding on a Falcon rocket and in a Crew Dragon. Yep.
Great. We're going to take some questions from the reporters that are on the line. The first one is from Jackie Waddles, CNN. Jackie?
Hey, folks. Thanks so much for doing this. So I wanted to check in about the parachutes. I know it's early, but were you pleased with how the Mark III parachutes performed today? And then with whatever testing that you still have ahead for the parachutes, what are you still hoping to determine?
Kathy, why don't you take it?
So today was the second system level test, what we're viewing as the second system level test of the upgraded, what we call our Mark III chute design. SpaceX has been doing a tremendous amount of testing over this last 6 months. And really perfected the design, did a system level test in December, did another system level test, obviously today in a pretty stressing environment, and then we're working together to get a new set of flight chutes and do 2 more system level tests prior to our next crewed flight test. Working through that with SpaceX and looking forward to further learning and hopefully, smooth parachute functioning on the next 2 system level tests. But we're very, very happy. If you saw it today, flawless execution of both the drogues and the mains, and both of those were the new system.
And I would say from NASA's perspective, we are so grateful to SpaceX for stepping up to the plate in a major way to move forward with the Mark III parachutes. There was a time we looked at the safety factor from a Mark II to Mark III. Mark II was good. Mark III was way better. Elon and I had a conversation. I said, look, if we want to move forward quickly, let's go with the Mark III, and let's get as much testing as we can possibly get done between now and the day we launch Crew. And they move forward very quickly. I don't know how many tests you've done at this point, but it's a lot with single chutes. And now we're up to the point where we're doing full system level tests with all 4 chutes. And so far they're looking good. So we're grateful to the SpaceX team. I also want to say thank you to the Airborne team. I've had a couple of conversations with the CEO of Airborne, told him what a high priority this is for our nation. And they've been working overtime to make sure these parachutes are developed and packed, and we're grateful for their support as well.
Yeah, I'd also like to say thanks for the Airborne team. They've been essential in this.
Yeah, this is an unprecedented amount of parachute testing I think that we've ever seen from a NASA perspective. So really great partnership across the NASA, SpaceX, and Airborne team.
Our next question is from Tim Fahrenholtz from Quartz.
Hello, everybody. Congratulations on the test today. I just wanted to ask if we could get some understanding of what the next couple months look like from an analysis perspective. How many people at NASA are going to be working on certifying the Dragon and the Starliner eventually for the crewed flight tests? And how does that compare to the experience during the COTS program?
Kathy?
So I actually worked on both cargo and then now crew, right? And I'll tell you from a station perspective, which is what the cargo program was focused on, it's consistent between obviously cargo and crew. What's different is that obviously crew's different, and the certification requirements for crew are different. So I think even though we have a small program standpoint, I think we're probably about 2 to 3 times the amount of NASA folks that are working crew versus cargo, the certification aspect of cargo, which to me makes a lot of sense because cargo was really focused, the NASA certification aspect was just focused on making sure the vehicle could safely dock with station. For crew, obviously, we need to make sure we're certifying the ground systems, the operations, the launch vehicle, and the spacecraft. So obviously, that's kind of 4 times the amount of work that you had to do for cargo. So that's kind of sized appropriately to me.
Okay. We'll take one more question from the phone, and then we'll go back into the room. And next is Irene Klotz from Aviation Week.
My question's for Elon. Does this in-flight abort test have any applications for programs beyond commercial crews, specifically for Starship? And also, does somebody have the exact wind speed at the recovery site? Thank you.
Okay. No, I don't think this has. It's not directly relevant to Starship, as we do not expect to use parachutes on Starship. Albeit, like the only reason Starship is happening is because of the progress made with essentially all the work done by NASA and others before SpaceX even started, and the support that we've received after starting, without which Starship would not be possible. And I didn't catch the second question. Wind speed and touchdown. Wind speed and touchdown, I believe was I think around 25 to 30 feet per second.
Wind speed at touchdown was 27 knots.
Yeah, 27 knots. Yeah.
Feet per second, sorry,
per
27 feet per second.
Yeah.
17,
So
17, yeah,
25,
20, yeah, I'm sorry, 20 not, that would have been a stressing test. Sorry.
It was oscillating, but it's
Yeah.
sort of in the high 20s. Yeah.
13 to 18 knots,
Yeah.
and I think we got like
But
27 feet per
it
second.
provides a good envelope in case for crewed missions.
Yeah.
Okay. Our next question?
Mary Liz with Cosmic Perspective. So the first thing I want to say is congratulations on this very exciting, momentous occasion. When you two walked in the room, you were beaming, and so I really want to hear from you what it was like. Where did you watch from? Was it the control room? Was any of your family with you? And what did you learn?
So we were in the firing room, and anytime you see a rocket launch is very exciting. And obviously, the significance of this particular launch and the test was something that we were particularly interested in, and to see that our families were not here with us. They were back home, but I did receive a text from my wife right afterwards and said everything looked good from her perspective. So they're obviously very interested in it as well, and again, every time I'm out here, this is just a special place, and when you get to see these rockets launch, it just gives you goosebumps, and I'm getting goosebumps again right now.
So no, the families weren't there. My wife also was in touch via text message, and learning that happened today, or maybe relearning or adding more context to the fact that we have an amazing team working through the issues with the weather and making sure that the vehicle, both Falcon and Dragon, were ready to launch. It was just impressive to be on the loops and listen to them disposition all of those things and make sure that we would have a test at all. So just getting to the point where we could launch, it was impressive to be there amongst the folks making it happen.
Cricket, we're going to take a question from social media quickly.
All right, I have a question from Ashley James Lee. She says, great test, well done. What would be the reason for the splashdown being earlier than expected on the timeline?
It wasn't.
I thought it was pretty much right on target for what we were expecting. So obviously we can go back and look at the data, but right now it's looking like things were pretty nominal.
Yeah.
Next question. Right here, third row. I don't know if I got it.
Thank you. Sawyer Rosenstein with Talking Space. So I know a lot of the focus is obviously going to be on the data from the Crew Dragon, but I was also wondering how much data you were able to get after the breakup of the first stage, and if there's any plans to use that data for possible future mission parameters for crew or for range or anything like that.
We lost telemetry on the first stage shortly after it exploded.
From the breakup of the vehicle that could possibly change design or engineering in the future of it?
It's possible, but it's too early to say at this point.
Gotcha.
Okay. Third row, I'm sorry, on this side with the hat.
Hi, I'm Jim Siegel. I'm with NASA Tech, and I have a couple of questions. Well, actually, one question, I suppose, for the two astronauts. I understand you went through kind of a dress rehearsal on Friday, so you got a chance to get into the capsule while it was atop the rocket. And I'm interested in what kinds of activities that you did while you were doing this. What systems did you check out? Did you eat? Did you take a nap? What did you do?
Right. So the dress rehearsal, actually, Bob and Doug were the ones that participated in that as the DM2 crew. And essentially it started from crew wake-up all the way through listening to a weather brief and then getting handed over to SpaceX at the suit-up room. And so they were then able to don their suits and go through that full process of checking the suits for leaks. And then from there, walking out to the vehicles, getting in the convoy, and going from our crew quarters over to the launch pad itself. and then going up onto the tower and walking out on the crew arm. They did not actually get into the vehicle because the vehicle wasn't in a configuration for them to get strapped in or anything. And so that was the point where that dress rehearsal ended. A lot of that data was timeline type data that we were getting, just making sure everything flowed together. The communication was good between all of the different team members. And I think there was a lot of lessons learned that came out of it, and people are making adjustments as necessary based on what we saw. Anything else? Nope. Yeah. Thank you. You bet.
Okay. Chris, over here in the second row.
Chris Abort with NASA Spaceflight for Jim and Elon. You mentioned that the decision will be forthcoming in the next few weeks as to whether DM2 will be short duration or long duration. I'm wondering from NASA's side why that hasn't been decided yet this close to a particular launch, especially with the U.S. crew segment reducing down in size in the coming months. And from SpaceX's perspective, is there anything that would have to be done to the capsule at this point, depending on what that decision is?
So by standard, if we go with the plan as it currently stands, we would launch, DM2 as a short duration test flight, and then we would have an operational flight test later with our 2 astronauts here, and they would do a long duration flight. So that's one solution, and that's where things stand as of right now. But we might look at making that first crew be a longer duration crew, for the purpose of getting the maximum amount of capability out of the International Space Station, with having, basically we'll be able to maintain a larger presence of astronauts on the space station for a longer period of time. So there's another competing interest here, and in order to make that happen, that first crew for DM1, the test flight, would need to be that crew would need to go through some additional training for a longer duration flight to do activities on the International Space Station. It also gives us opportunities to do extravehicular activities that may not right now be scheduled, but may pop up based on things that happen on the ISS. And it's always better to have more crew on board for those activities rather than less. If we end up with 1 American on the International Space Station, then that American will be doing the EVA. And we want to make sure that we give us the best chance of success. Now, I'm not saying that this is the direction we're going to go. We just haven't decided yet, and we're working through it. But the good thing is, given what looks like to be a very successful test, we now have options. So that's a positive thing.
From a SpaceX standpoint, we'll make sure we're ready to serve whatever needs NASA may have, and so whatever decision is made, that we can support either.
Yeah, thank you.
And we've insured the vehicle. We've been working with SpaceX to ensure the vehicle really has had the capability to be able to have a longer duration mission really over the last 6-7 months. Been working with SpaceX. Just like Jim said, you always need to have options when you're dealing with these types of missions.
Emery in the fourth row.
Hey, question for Elon. Obviously, an abort scenario is a different kind of stress on the
high stress,
yeah. I'm wondering if that impacts reusability. Do you get fewer flights out of a Crew Dragon in that scenario, or is that to be determined?
I'm not sure. We would really require a lot of thought and, of course, support from NASA to refly a Dragon that went through an abort. I hope that there's such a rare event that the circumstance never comes up.
I'll tell you one thing that impressed me. When we looked at the ballistic reentry that Nick Hague went through on a Soyuz rocket just a year ago, he was up around 6.5, almost 7 G on that ballistic reentry. Now, he was at a much higher altitude, but this entire launch abort sequence that we just saw, the highest G state was about 3.5 Gs, and then when it was coming back, we're looking at like 2.3 G, which is that's impressive. It looked like it would have been maybe a rough ride, but the data didn't bear that out, and I think that gives our astronauts some confidence that the ride might not be so bad if we have to execute one of these launch abort capabilities.
Yeah, the launch abort capability is in principle capable of up to sort of six or more Gs, but it limits the acceleration to maximize the comfort of or safety of the astronauts. So it's reconfiguring depending upon what achieves the maximum probability of safety and minimizes injury.
Next question. To the writer.
Hi, Stephen Clark from Spaceflight Now. Can someone update us on the condition of the spacecraft after the splashdown? Have the recovery teams got to it? Is it on the boat yet? And seats from Russia to get through the year or into next year, or is that still ongoing?
So at this point, as much confidence as we have in the team, I think it's probably not prudent to go that direction. I think it's important that we have options. Again, we want to increase our option space and make sure that the International Space Station has a continuous American presence. And so we're not ready to make any adjustments on that front. We're going to buy another Soyuz seat.
Sorry, I was just looking to see if I'd received an update, but I think the recovery vessel is just securing it right now, so we do not have additional information at this time.
Question here, second row.
Congratulations, Robin from Supercluster. Have you flown the Dragon simulator in Hawthorne, and have you tried on the suit multiple times?
I've tried. I've tried it on the helmet, and I've flown the docking simulator several times.
Are you good at it?
You know,
I'll tell you, I am. I nailed it first time, and of course every time since.
But you had Bob and Doug's help.
I did.
I know.
I think it's good. But having played a lot of video games as a youth is probably helpful. But it's the Dragon actually approaches the space station very slowly, so it's actually very much slower than people realize. So I think it's not very difficult to dock with the space station because it is approaching very slowly, and you have very fine controls. In fact, you can adjust between sort of course corrections and fine control corrections. So you can adjust the thrusters to have sort of nuanced effects, or like broad brushstroke, fine brushstroke, and I think it's pretty straightforward to dock in light of that.
Tim?
Tim Dodd, the astronaut. Question for pretty much anyone who can answer it. Elon, Kathy, Jim, the exact sequence of events today. It was kind of hard to tell actually when we're seeing the feed, and of course from the press site we just saw a cloud. Was it an engine shutdown was the initial trigger, and then did the Dragon, was the actual abort sequence? Was it the Dragon was triggered to abort, and then the engines shut down after that? And then, or was it like the shutdown of the engines? And then the sequence of events was actually kind of confusing and hard for us to figure out. And of course, we didn't really see much. Can you actually run us through what exactly was programmed when and how it all triggered and what triggered what, I guess, the chain of events?
Actually, I was thinking about posting the time sequence of events, what occurs in the course of about 700 milliseconds. It's really way more than a human could do is occurring in a fraction of a second. But the engines there's a command to the engines to shut down, and then the abort system then presses up very rapidly. The Super Dracos are ignited. It initiates separation from the upper stage. But all of this is occurring in literally a split second, and Yeah, and it's really quite remarkable how quickly those engines reach full thrust, and all 8 of them do, and then it controls via differential thrust of the 8 Super Draco engines, and so it's making those thrust adjustments at the almost the millisecond level. It's very, very fast.
And then the engines were shut down after that. So
Yeah.
Then the launch vehicle, the first stage engines were all shut down at that stage.
So just to clarify, like the actual, I'm just trying to still figure out if it's like because the engine shut down that inherently triggered the abort, or was
No.
that all pre-planned and hard sequence basically?
As part of the abort sequence, like if the system detects that there's the things are severe enough to initiate an abort. In this case, we set the abort triggers to be super low, such that they would occur at a very specific sort of velocity. And as part of the abort sequence, one of the things that's done is issue a command to the engines to shut down. But you don't wait for them to get fully shut down. You issue command shutdown, and then you pressurize the abort system, the Super Draco abort system, and a lot of these things are happening in parallel. So you're not waiting for one thing to occur after another. A lot of them are occurring in parallel. But it's saying shut down main engines, cut thrust, and then pressurize the abort system and fire up the abort system with all 8 Super Dracos. It's capable of working even if one of the Super Dracos does not. So it's got engine out capability on the abort system, and then it's going.
So remember what the goal is. The goal is to get as much separation from the booster as possible as soon as possible. And what we saw is we got some data on this initially. It was correct me if I'm wrong, but it was like a kilometer of distance between a mile of distance between the booster and the Dragon, and it was just in a matter of seconds that separation was created. So that just shows you the capability, and all the while never exceeding 3.5 Gs. I mean, that's really amazing.
Yeah, even if it were to be the case that the booster engines continued firing after shutdown command, Dragon has enough thrust to accelerate away from the booster very rapidly. Yeah.
Well, thank you so much. This is going to conclude our press conference. I'd like to invite if any of our speakers have some closing remarks.
I think we should have our astronauts say a few words.
Well, again, I'll just reiterate today was a very important day for us in the test program, and I think for all of the astronauts, we're very excited at what we've seen to this point, and we look forward to seeing the rest of the results. And we look forward to our continuing preparations for Doug and Bob to launch, and then after that for Victor and I to go up. So we're excited where we are right now. We're excited to continue training, to finish up the testing, and get ready for launch.
Well said. Important step on a long journey, and we're looking forward to the data analysis and learning more about the test today and the recovery efforts. Like I said, those are still going on, and we're grateful for all the hard work to get here, and looking forward to the work that we have left to do.
Well, thank you all. For more information, you go to nasa.gov. Thanks. Have a great day.